Solving systems by graphing. So this first page here is just a review of the 3 types of forms. So I'm going to do that fairly quickly, and you can skip ahead in the video if you don't need this review, but I'm going to review these really quick. Okay, so the first form that we dealt with was slope-intercept form, which is written in the form of y equals mx plus b. So remember, this is our b value, which represents our y-intercept. So on this, our y-intercept is -5. And then our slope is 1/3, meaning we're going to go up 1 to the right 3. It's a positive 1/3. And that's slope-intercept form. Standard form was written in this form, this ax plus by equals c. And there's different methods in which I taught you in order to be able to graph these. Now, the method that I kind of prefer is just to convert it into slope-intercept form. Sure, you could find the x and y intercepts, might be a little quicker, but particularly for this lesson, because we're going to be kind of finding intersections of lines, it might be better to do slope-intercept form because it's going to be more exact in terms of some of the points that we're going to plot along the way. So I'm going to convert it into slope-intercept form. So in slope-intercept form is isolating y. So I'm going to isolate y here. So I subtract 4x from both sides. So I'm going to have -2y equals -4x plus 12. And then divide by -2. I'm going to have y equals -4 divided by -2 is positive 2x. 12 divided by -2 is -6. So there, now it's in our slope-intercept form. So our y-intercept is 6, or -6, should I say. And then our slope is positive 2. So I'm going to go up 1 over, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And that's standard form. And then the third form of linear functions that we dealt with was point-slope form. Now, point-slope form is written in this y minus y1 equals m parentheses x minus x1. So it gives you a point, and it gives you the slope. So from looking at this equation, remember it's opposite of those. So our point is going to be at -1, positive 5. And then our slope is -2/3. So -1, positive 5 would be way up here as our point. And our slope is -2/3. So I'm going to go down 2 to the right 3 from that point to plot the other coordinates. Okay. All right. And that's point-slope form. So when we're solving systems of equations by graphing, we're going to be seeing these in all of these different forms. So let me jump into that. Okay, so this is what it says. The solution to a system of functions is where the lines intersect. The solution is typically written as an ordered pair. If the lines are parallel and never cross, there's no solution. If the lines are intersecting, aka the same line, there are infinitely many solutions. So number 4 says, solve the following systems by graphing, write solutions as an ordered pair. If there's no solution, write no solution. If there are infinitely solutions, write infinitely many solutions. Okay. So A. So we have 1/2 x plus 4, and then 3x plus y equals -3. So I'm going to graph this first one. So I'm going to graph this first one in blue, just so that we're clear on which is which. So the y-intercept is 4. It's in slope-intercept form, so I have my y-intercept is 4. And my slope is 1/2, so I'm going to go up 1 to the right 2. Positive slope of 1/2 there. Let me put some more dots in this direction, and that should probably be okay. Now let me do this second equation. I'm going to do that one in red. So I have 3x plus y equals -3. This is written in standard form, and I generally have been suggesting convert it into slope-intercept form. So I'm going to rewrite that equation really fast up here. So I'm going to isolate y. It says 3x plus y equals -3. So I want to move that positive 3x. I'm going to get rid of that positive 3x. I'm going to subtract it from both sides. So I'm going to have y equals, once I subtract that 3x, it's going to be -3x on this side, and then the -3. So now it's in slope-intercept form. So the y-intercept is -3. And the slope is -3. So I'm going to go down 3 to the right 1. So it has that nice slant. And this kind of goes off there. Slanting downward as you read it left from right. We continue that pattern this way. So I've graphed both lines. And as we talked about prior, the solution to a system of equations when graphed is their intersection, where they cross. So if I look at this graph, it looks like they cross right here. And the coordinate of that point is -2, 3. So the solution is -2, 3. So again, when you solve a system's equations, you just need to graph both equations and then locate their intersection. So B, the first equation is written in point-slope form, and the second equation is written in slope-intercept form. So on B, I'm going to do this equation in green. So that equation's in point-slope form. So let me just identify the point. The point would be at -4, -5, and our slope is 3/4. So our point's at -4, -5. Remember, it's opposite of these. Okay. -4, -5 would be here. And then our slope is positive 3/4. So that means from that point, I'm going to go up 3 to the right 4, up 3 to the right 4. Here. Up 3 to the right 4 here. Up 3 to the right 4, about there. I think I can draw another point down here. Yeah, okay. All right, that's that line done there. The second line, whoops, sorry. The second line is written in slope-intercept form. I'm going to do that one in blue. So the y-intercept on that one is 5. And it says -x. Now remember, there's like a hidden coefficient of 1, right? So this is like just like -1/1. So I'm going to go down 1 to the right 1. Oh, I was going to do this in blue. Okay. Here, here, here. So boom. I actually don't really even need to keep graphing because I can already see their intersection. But I want to make it look pretty. So here we go. Both lines are graphed. And the solution is where they intersect. We can see a clear intersection right here. And that coordinate point is 4, 1. I'm going to do more. I'm going to keep going. I'm going to keep doing more. All right, I'm going to do this one in blue. This is written in slope-intercept form. Y equals mx plus b. The y-intercept is 4. The slope is -3/2, meaning I'm going to go down 3 to the right 2. Down 3 to the right 2. Doing that from that point, from the y-intercept. Down 3 to the right 2, down 3 to the right 2, down 3 to the right 2. I'm just going to continue that, because I'll put one up here as well. That line is graphed. Now the second line, why don't I do that in red? That one's written in point-slope form. So let's identify the point. So it's the opposite of that -1, which would be +1, and opposite of that +2, which would be -2. So the point identifies that +1, -2, and the slope's at 3. I'm just going to write m equals 3 here. Okay, so the point is at 1, -2, so that would be here. That's where I'm going to start. And the slope is 3, so +3. So I'm going to go up 3 to the right 1, up 3 to the right 1, up 3 to the right 1. So it would be here, here, here. Let's continue it a little bit. And again, I already see the intersection. I kind of already have the answer. So I don't need to be such a perfectionist with the rest of the points because I already see the answer. I see the answer right here. Oh, I was going to do that line in red. I don't know why I switched to black. So it doesn't matter. So the intersection is right here. That's at, what's that at? 2, 1? Yeah. Let me show you D. Now D, they're both written in slope-intercept form, and this one's kind of interesting, so watch closely. I'll do this first one in green. Y-intercept is +3, slope's -2, so I'm going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. All right. Second one I'll do in red. That's also written in slope-intercept form. The y-intercept's -1. And the slope is also -2 on this, which is interesting. So from that point, I'm going to go down 2 to the right 1, down 2 to the right 1. So down 2 to the right 1, down 2 to the right 1. So look at these things. They have the same slope. They're kind of consistently going at the same rate here. Down 2 to the right 1, down 2 to the right 1. But they started at different spots. Their y-intercepts were different. The green one, the y-intercept was 3. The red one, the y-intercept was -1. So they had the same slope, different y-intercept. If you look at these lines, they're never crossing. They're parallel. They're never crossing. So in this case, since they never cross, there is no solution. Remember, the solution to a system of linear equations, when you graph them, is where they intersect. So if they don't intersect, there's no solution. So maybe these 4 examples were enough, but let me show you a couple more because I want to remind you of these kind of weird ones with just the X and the Y. So let me get this one out of the way first. This one I'll do in blue. So the point would be, since it says -1, it's going to be +1. And since it says -2 for the y there, it's going to be +2. So the point identifies at +1, +2. And then the slope is 3. So 1, 2, that'd be the point I start at. The slope's 3. So from there, I'm going to go up 3 to the right 1. All right. So I'm getting that one out of the way. Now, the second equation is just y equals -1. So to remind you, if we have an equation that says y equals -1, I'll do this one in red, that is going to be a horizontal line where y equals -1. So it's going to be this. So if you notice, like y equals -1 is that horizontal line. Everywhere on that line, y is -1. Okay. So its intersection is right here, which would be at 0, -1. Let me show you F. I'm going to do this first equation. I'm going to do this in green. So the first thing I'm going to do is, since it's in standard form, my personal opinion is I like to convert it into slope-intercept form. You can find the x and y intercepts. That's one way to do it, but I'm going to convert it into slope-intercept form. So let me rewrite that equation really fast over here. Okay. All right. So now I'm going to convert it into slope-intercept form, which is basically just isolating the y variable. So I have a 2x. I'm going to subtract 2x from both sides. So I have that -3y. There'll be a -2x over here now. And then divide by -3 to isolate my y. -2 divided by -3, that doesn't simplify to a whole number. I'm just going to leave that. Since negative divided by negative, I'm going to leave it as a +2/3 x. And then 6 divided by -3 is -2. Okay. So that equation, I got a y-intercept of -2. Plot that. And then my slope of 2/3, I'm going to go up 2 to the right 3. And this is where we're looking. Let's connect that. Okay. All right, this is the one I really wanted to show you. This x equals 6. So remember, when it's y equals, it's a horizontal line at that y value. When it's x equals, it's a vertical line at that x value. So it's a vertical line at x equals 6. So the solution is where they cross 6, 2. Okay, so I hope that was enough examples to get you going. I feel like I did a lot of them. So I'll let you try the remainder of those, okay? I'll let you try the rest.